Hello and welcome to special series of LVCOM lecture collaboration with the Cognifront software. In this lecture we will see projections of point, which is the chapter of engineering graphics. When we talk about any sort of projection of point, it comes that any single dot would be coming in various sort of forms, like on the front view, on the top view, etc. We will see brief about all these things in this lecture. My name is Arpan Pandit and we will see the further how we can draw projections of plane. As you can see over here, when we talk about any sort of projections of point, line, plane or solids, what we must understand, to draw any sort of object we must have some sort of information in the beginning. The first one would be object. What is our object? Either our object is line or point or any sort of plane. Now when we talk about any point, if you see a single point, if I am talking about point and I want to represent point, then what I am doing, I am using this marker, but I am seeing it from this side. So what I can see is only a dot, which means that if I want to locate these points projection either in the top view or in the front view, we need to have some specific requirement. Now for the same thing only, what if I am taking projections of line? Over here we can consider this marker as a single line. How this line look in the front view and the top view, that decides upon the various quadrants. About projections of plane, if we are talking about any sort of plane, a plane is a thing which don't have any sort of thickness, but it have some definite shape. Over here I have a rectangular plane. So all these parameters we need to check when we are talking about any sort of projections of plane. Now this thing clears, this is our object, this is our object, either this would be our object. Now what we will see next is observer. Now when we talk about any sort of observer, which means that a viewer, now it depends upon the viewer from which side he is seeing. Let's say if we are talking about a point, if I am seeing it from this side, then I can consider it a point. But what if I am seeing this object from the side, I will see a line. Now so that is very important, that from which angle observer is viewing and what is the quadrant of observer's viewing purpose. Now the third one would be location of the object. Means that if we consider location, now if we are having a plane which is horizontal, we can call it horizontal plane. But if we have a plane which is vertical, then we can call it vertical plane. Now we have denominated all these terms. If we are having horizontal plane, we will consider it as HP. HP means horizontal plane. If we are having any sort of vertical plane which is having some sort of which is having minor thickness but have definite shape, I am having a vertical plane, which means that it is called as VP. Now when we talk about any sort of projections about all these things, we will see HP and VP used most of the time. So don't get confused. Horizontal plane stands for HP and vertical plane stands for VP. Now when we talk about above and below, if we are talking about any sort of horizontal plane, what will happen? Either object would be above horizontal plane or it would be below horizontal plane. That must be very clear. Either it would be above or below. It cannot be this side or this side because it is not having any sort of thickness, as I said you, either above or below. Now when we are talking about VP, what things happen? The term used is in front and behind. This is our vertical plane, right? If the thing is on the front side of the vertical plane, then it is called the object is in front of the VP, and if the object is this side of the vertical plane, then it is called as behind VP. So when we talk about above and below, it represent with the horizontal plane, right? Above and below for horizontal plane, and in front and behind stands for vertical plane. That's the basic fundament for any sort of projection that must be considered. Horizontal plane HP, vertical plane VP, above and below for the HP, and in front and behind from the VP. Now it is very interesting to learn the effect of the position, that is front view and top view. When we see many sort of projections, we will have a XY line reference. How this XY line works, we will see in our next slide. If we see some sort of notations, what are the notations basically? When we are talking about any sort of projections, these notations must be followed. What are the notation? First would be object. Which is the object? Either it is a point or a line. We are talking about projections of point and line only now. Apart from this projection of plane and solid, we will consider it on the later part of this chapter. Now when we see object and we are having point A and point B, notation is very important thing. If we denote any portion wrongly, then our object can be false. If it is top view, then object is denoted by small a if it is point, and if it is line, then it is denoted by AB, that's small. If it is front view, then it is denoted as A dash if it is a point, and A dash B dash if it is a line. Now what if it is a side view? It would be A double dash if it is a point, and it would be A double dash B double dash if it would be a line. So these things must be clear. If it is a top view, only small. If it is front view, a dash would be added. If it is side view, 2 dash would be added. Now this thing would help you in denominating all these parameters. Now if you consider in your way, then also you can choose, but this method is very suitable to get better idea of all the object parameters. Same system notation can be used in case like numbers. If it is top view, then it would be 1 point, line 1 2, front view 1 dash, side view 1 double dash, etc. Very simple. Top view only letter, front view 1 dash would be added, and side view 2 dash would be added. That's very clear. Now we will see next portion. Now when we talk about any sort of plane, what are the planes and how they are located? I show you a vertical plane over here like this. So this is a graphical representation of this. You can see over here vertical plane looks like this. Horizontal plane, which I show you like this, a horizontal plane. Now, these two planes would coincide with each other at 90 degree. The both will be inside at 90 degree, which creates what? Which creates a XY line which is intersecting in the middle of the portion. There is an intersection point where both these points are intersecting. It is called as XY line. This XY line is very much important for all the projections of plane, solids, point or line. This is a basic fundament. Horizontal plane would be lying horizontally, vertical plane would be lying vertically. Where these two planes got intersected with each other, a line formatted over here, that is called XY line. Where these two planes intersect, called XY line. That's very basic fundament. I am repeating once again. Where these two planes coincide, XY line generates. Now, because of this four portion, because of this plane intersection, we got quadrants. Now, we have heard many things about first quadrant, second quadrant, third quadrant and fourth quadrant, either in the maths or in the physics. But here is the graphical representation of this, how this quadrants generates. The first quadrant, the second quadrant, third quadrant and fourth quadrant. Everything is at 90 degree. If we see 0 degree, then 90 degree. 0 to 90 degree is first quadrant. 90 to 180 would be second quadrant. 90 to 180 would be second quadrant. 180 to 270 would be third quadrant, and 270 to 360 would be a fourth quadrant. So 360 degrees divided into 4, which means that we have got our 4 quadrant points. Now, we are very much clear about our planes. Now, what is next? The next thing is observer. We are observing any portion from this point where we can see clear XY line, because we need some sort of projections. If we see from this side, then we can see the full XY line. If we see from this side, we can only see a single point. That would be X and Y together. So that's not feasible at all. Now, when we talk about front view, what is front view? Observer's direct vision would be front view. If I am seeing this portion in front of my eyes, if I am seeing this portion in front of my eyes, then it is called as front view. If you are looking from this side, your front view would be over here. Now, what is top view? If I am seeing from this side, it would be my front view. Then if I am seeing from this side, it would be my top view. What I am seeing from the top would be, if I am seeing like this, then it would be my top view. We talk about side view. In the side view, we can only see this XY dot only. Now, this quadrant pattern, if observed along XY line in red arrow direction, which means if this direction, we can see only side. Hence, we need to understand the illustration properly. Like see, we are seeing from this side, and you will see the proper quadrant feature. This is our horizontal plane, This is our vertical plane. This is the point where both these points get intersected over here. In 3D you can see this is the graphical representation of this point. Now what will happen? X and Y would be in the same line. So I have noted X and Y I can see only at one dot only. This is our vertical plane. This is our horizontal plane. Our observer would be from this side. This is the observer. Observer side would be this. This is the observer. Now this would be first quadrant. This would be second, third, and the fourth one. You can understand clearly first, second, third, and fourth. These kind of graph you have generated so many times in your various subject like maths and all that, in your basic schooling also. Now what is the next parameter? Point A is placed in different quadrant in its front view and top view. Now we can see front view easily, but we cannot see top view. So what we have done, we have rotated it downward 90 degree in the clockwise direction. How? Let's see. As you can see over here, I have just denoted vertical plane and horizontal plane over here like this. Highlighted for you only horizontal plane and vertical plane like this. What is our first thing? What we are understanding? Point A is in the first quadrant. Now this is our point that's in the first quadrant. How it will look like? It is point A, basic point. It is our basic point. In the previous slide I have said you that if we are looking for the front view, it would be single small letter. If we are looking for the top view, it would be A dash.